Now, team, talking about that application, right? Okay, there are two components to it. Listen to me very, very carefully, everyone. There are two components to your Facebook-like application. Okay, and I hope everyone do agree upon it. One component of that is hardware. And there is second component of it, which is software. Now, everyone here, I'm sure everyone is aware of what's the basic difference between the two. Hardware is anything that you can touch, that you can feel, that has a physical form. Whereas software is basically what runs on hardware. So literally, if this is an example that I give for someone entirely new to these technicalities, is like, if you switch on your phone, your cell phone, everything that you can see literally from booting that up to kind of shutting it down, everything that you're looking at on the screen is all software. Okay, so just keep that simple thing in mind. So there are two components to run for running, or there are two components to run your application for your global users. You have to set up, you have to configure the hardware part of it for Facebook. Because you see, when I say that Facebook is being used across the globe, it should be running somewhere, right? Otherwise, how would I be able to access it? You have Facebook application on your cell phones, right? You click on that and you're getting access to your Facebook profile. But where is it running actually? Do you know, team? Anyone? Any guesses? Where is it running? What's that hardware called? What in general, in fact, I'm not specifically asking what company and what exact specifications, but generally, what is it called? Where are we running a Facebook-like application? What that entity is called? The hardware entity? Anyone? Any guesses? Exactly. Very well. Yes, we have such huge data centers in which we have servers, right? To be very simple, it is, it comes down to a single end concept, which is server. A server, as simple as your laptop. I'm just oversimplifying it, I know, but as simple as your laptop, right? A server, which is capable of serving the application. That's a hardware. And then on top of that, you will run the software. Software, which will have the code, which will have the functionalities that you want for Facebook and everything. Right. Now, team, listen to me carefully, because this is where it gets all interesting. Okay, I want your entire attention to it. Keep your cell phones aside. Okay, why? Just because I'm talking about Facebook, it doesn't mean you have to check your feeds and look at your connections. Okay, just be aware and don't get distracted. Okay. Now let's listen to me carefully. So now, as far as initializing this process, as far as getting started with it for this project, we want to create Facebook. That's what we have come down to, or that's what we have decided. We want to create Facebook-like application. Now, someone should begin it. The planning and everything is all done. Just like for our house, the blueprint is all ready. Now it's time to set. Now it's time to go for setting up the foundation and then going about brick by brick building it, right? So we have to actually start the process of creating this application. So just like you'll have the people building the house for you, the first person that will come into picture if you're setting up an application like this is a person who will be writing the code for Facebook, right? Because otherwise, how would you have that's Facebook running? So you see, we require a person now who can use its machine, his or her machine, laptop. Now, please pardon me for my drawing. Okay, it's really, really bad, I know, but I'm just saving some time not using shapes. Okay, so the person is using some laptop, keyboard, more of the machine, the desktop, and creating an application code for us. Isn't it? This is the application code, the Facebook application code. Isn't it? Behind every application, there is a code. Otherwise, how would it run? Now, team, I want a quick info. I want a quick response here from your end. What do we call this person? Everyone, I know, everyone is aware. What do we call this person who writes the code for us? Exactly. It's a developer. It's the developer, the magician who creates all of this for us, right? So developer, exactly, very well told. A developer is what will be doing this task for us, setting up, creating a code. Now, team, we want to use this code further, right? I mean, because there are many things that we want to do it. I want to run this code onto the hardware and everything further. So it is expected that you should not be keeping this code on a machine, isn't it? I mean, obviously, right? Because there might be 10, 20, 30 developers working on different functionalities of the code. So you want a single place where you can keep the code so that all of your colleagues, all of your other developers can work upon it. So that's where it is required, team, remember, to push this code to an appropriate code repository. Okay, I'm calling that phase as code, but basically it's a code repository where we will be keeping our code in the most secured manner. The code is kept in the reliable manner. The code is kept so as to have as much scalability as possible. So I don't have to worry about the storage aspect. The code is kept so as to keep track of changes over the time that are happening. The code is kept in a way that I can control the access, who can access it and to what extent. Right. So I want a sophisticated place where all of this source control management can be carried out. Do you know, team, any example of such a particular service or such a particular offering? Not in general. Do you know what a particular exactly? Everyone, right? You have, I mean, whether or not you have used it, but I'm sure everyone have heard of a concept called as Git or GitHub, right? We have Bitbucket and many more, I know. But at least a Git is GitHub or Git is something that you must have already heard, right? But that's not the point. The point is like, this is a code repository. And yes, we can use the services like that, Git, GitHub, Bitbucket, S3, code commit, many more to store our code in there. Now, team, storing the code is one thing. What about the next process? Right. The next process should be, we want to, now this next part, no, this I'll tell you because I don't want you to guess upon it because you might not be aware of it already. Okay. The next process, what happens on top of it, on the code, when you store it there. Okay. Now, testing is afterwards. That's why I did not ask you this question. The next process is building your code. Okay. Now, building is like, I'll tell you. What could be the example of it? So let us say again the same example. Let us say you're building the house, right? So for the same example, you don't use a raw material just like that, right? For building it. I mean, you may want to create a mixture of it to be able to apply as a foundation for applying as a kind of cementing the sort of bricks together, right? So that's what. So you require at times some intermediate outputs, not the entire output, some intermediate outputs. And for that, we have to build our code. This is the place where we compile our code, build our code as we call it, and we can create some intermediate artifacts. Okay, artifacts could be like something like you are using a Java code and you want to create a jar file. Or you are working with containers and you are creating a Docker image there or container image there. So many things are possible technically, but timing is, remember, this is the place where you can generate, you can create some intermediate outputs as I would require. Compile, just think of it for timing with compilation of code is like we're creating some intermediate outputs, okay, which will be required further. Okay, so we don't use the code as exactly like that. We may want to convert it, we may want to change it, we may want to create some intermediate packages and artifacts and outputs, which will be used further. We'll see that with example later on. Timing, just remember, build is a process which is important to make sure that your code is consistent going further. And as well, whatever the intermediate packages, artifacts, outputs are required, as I've given you some examples, right? Jar file or your Docker image or something like that, it can be created in this middle phase. Now comes the next point, right? The next point is, or the next phase is, as you might know, you have already guessed it, right? What it could be. So code is built. What you have to make sure before the code can go into production? You must do what on that? Exactly. You have to test it out. You have to make sure that your code is satisfying all the requirements. We have to make sure that the code is satisfying, the code is complying to all the requirements, to all the tests that I'm putting across. Because you see, the thing is like, try to understand the consequence of that. You don't want your Facebook, you don't want your users to suffer your application, right? Because there might be a bug. Now, you see a bug, a problem, a shortcoming in the code, or rather the final application could have a big impact on the revenue, the reputation, and everything, right? So it's important that you have to test the code out thoroughly. No. It is software testing. It's software testing. It is exactly. So we're testing our software rather. We're testing our code rather, not software rather. In fact, I would say it's testing our code to see whether it is satisfying all the requirements, right? To make sure that the code does not have any bugs going further. The code is complying. For example, you may have some security compliance, right? You don't want certain rules to be there. You don't want certain open ports to be there. You don't want certain firewalls to be open, something like that, right? So many such things can be tested over here to see that your code is complying onto all such requirements. Yes, now this is interesting. In fact, this is one thing I have told you in the last session as well, that testing is basically not, it does not happen only at this phase. This is true only for this phase. Is that testing, even though I have kept it over here, it does not happen only here. Yes, it is a formal place where the testing should be happening, but the testing as well happens at the code phase. It happens at the build phase. It happens even further in the pre-production stage. It happens in the production stage as well. So there are different kinds of tests that will happen at different phases. So just be aware, yes, formally I have told that there is a testing that is happening, but testing happens all along the process, all over the process, entirely throughout the process. And there is no, I mean, you cannot confine it to a single place. It will be happening throughout. Every place will be having some or other test that will, yes, exactly. Like you said, unit test is there. You have component testing, you have load testing, you have system testing, you have A/B testing, you have what? Integration testing, right? You have, I mean, there are many such tests that we can you have user acceptance testing, right? So different kinds of tests are there that will happen at different places, but at least this is the formal place where I'm considering that at least the minimum tests are carried out so that my code could move further. Right? Now the next phase. What do you think? We have discussed it in the last session. Do you remember what was the next stage? Code, build, and test, and what? Exactly. Continuous it's continuous. Exactly. So I'll tell you the very next phase. So exactly what you told is correct. You see, the first three stages, you can see over here, these first three stages, they are all taking care of your code. Okay, they're all taking care of the code, which is basically making sure that your code is of the best quality possible. Right. Now it's come down to taking it further for the deployment. But the problem here is, you see, there is a problem. I don't have hardware yet. Do you see anywhere we have provisioned the hardware? No, right? Yes, deploy is the ideal phase I should be going for. But the problem is I have not yet provisioned the hardware anywhere. Right. So that's why there is one more stage I will have it here, which is important, is we call it the provision phase. I need to kind of change it a bit for that. I'll just make it a bit longer. Okay, so next phase, team, let me just draw it once more, is, as we call it, provision. Now, what do we mean by provision? So provision is the phase where you are spinning up the hardware that you want. You see, there are two components to it, no? Software, you see, we have tested it over here, this one, and with these three phases. And the fourth phase or the fourth stage is, listen to me carefully, provisioning is basically spinning up the hardware that you require, isn't it? For example, in the Facebook case, we have servers, right, that are holding on to your Facebook application. Exactly, that's what we want to spin up our servers where our application will run. So provisioning is spinning up your infrastructure, spinning up the hardware that you want for your application, right? And thereafter comes the final stage, which is what you were all looking for. It is the deploy stage. The deploy stage is where you'll be running this software onto the provisioned hardware. Okay, so this is more of for the, you can see for the hardware. These three phases are for software, and deploy is what? Software running on hardware. Okay, and then there is a small, last but not the least kind of phase remaining. We call it the monitoring phase. We call it the monitoring. Exactly. Monitoring is like, even after the Facebook is deployed, right? The team, the employees, they're continuously checking in the backend, right? If it is working well, and what is the performance, and what is the sort of lag, or if at all there is some latency, if at all there is some issues. So all of that comes under monitoring. Once you deploy your application, it does not end there. You have to go further and make sure that it's running the way you want. So monitor comes under that. Okay. Now, team, I hope that you agree that if I go again, I know basically this process is, as you call it, software development life cycle. Okay, we call it software development life cycle. Now, again, listen to me carefully. There might be various other fields. I know the release process, the release phase, and there might be different names being given at different literatures and different sources. But I'm just putting out a very simple process for you so that everyone can relate to. This is called as a software development life cycle, wherein I can develop a software by going through these all phases. Now, team, I'll require a quick confirmation from your end. Do you agree that if I follow this process, I'll get a working software at the end of it? Do you or do you not? A working software, yes, we can add more functionality, we can add more phases, and we can make it better. That's fine. But with this simple process, if I follow, do you agree that we can accomplish the task that was given to us? We will have a software running for our end users, right? Excellent. Excellent. Now, team, listen to me carefully. Why we are discussing all of this? Now, this is the interesting part. Now, if you remember at the beginning of all of this discussion, I told you that there is a person who is doing the coding for you, and we call it developer. So developer's job is to develop the code, but to take it from there and to do testing on it, to make sure that it is put to the market, to make sure that your code is converted into a product in a reliable way, in a stable way. All of those things are taken care by another team or another people or set of peoples. We call it a team with the name operations. Remember. So there is a developers team, there is an operations team. Operations team job is what? Operations team job is what? Operations team is taking that code from developer, and in simple words, I'm putting it, it will do whatever it takes to put that code to market, or to put that as or to create that as a product at the end of the day. Okay, in the reliable way, in the most stable way, whatever that it takes to do that, operations team will do it. So team, the bottom line here, try to understand, is there are two teams involved in the software development lifecycle. There is a developers team, and then there is a operations team. Okay, developers team job is to develop the code. Operations team job is to take that code further in the process and deliver it to the market in the most reliable, stable product, in terms of a product which can be used across by the entire globe. Right. So team, that's where, in fact, this is what's the context I wanted to give you to. In fact, you see, this is the same diagram I had discussed in the last session as well, but it was required before I could go further. Okay. So there are two teams which are part of our discussion right now. The first team, as we can see, if you discuss, as I have discussed, one is the development team. And then there is a operations team. Then there is a operations team. Okay. And somewhat later on, or in just some time right now, I'll show you how that development and operations basically we can basically create a DevOps out of it. But there is a interesting thing here. You try to understand, isn't it? The thing is, like, even before DevOps, this is one thing I want to emphasize on very, very clearly, is one misconception that people, or I've seen students, they do have, is they think that development and operation came with DevOps. No. Okay, development and operations team, they have been long there. They have been always been there ever since we are developing the softwares. Right. So development and operations team, they have been always there. DevOps is very recent in the context of since when development and operations have been there. Okay, but what's so special? Because you see, even if you go for agile approach, even if you go for waterfall approach, different approaches are there, right? Before DevOps. Even in those approaches, the development and operations teams used to be there, and they are still there. So what's so special about DevOps? That's what we have to understand right now. So team, can you please confirm before I go for actual DevOps now and tell you what's so special about it for these two teams? Is it clear right now, the things that we have until now, that we have discussed until now? Can you please confirm quickly before we can move ahead right now? It's very interesting discussion that you'll see further. Excellent. Excellent. No, don't worry about the build stage as such for now. We'll discuss that further, okay? Because build stage, now I'll tell you, it will not make a lot more sense until I show you with a demonstration. We'll see that. We'll see that. I'll give you a simple example. For the build stage, you might have heard an application or a tool called Jenkins. Jenkins you have heard, right? Jenkins is that tool that we use it very often with build process. Now it's more than that, rather, I'll tell you. Jenkins, we can use it for testing as well. We can use it for setting up the overall process as well. I mean, there are many more uses to it, but Jenkins can as well be used there for compiling your code and creating such artifacts. With Jenkins file, we have it in there. I mean, those things we'll see further. Right now, I don't want to confuse you anyhow. But timing, remember, there are two teams involved in this operation. Now, team, I'll tell you a history of a very big organization. Okay. A very big cloud platform. Okay. I mean, right now we're discussing generals of, basics of DevOps, but still, I want to give you a big use case, or rather a big story somewhat. So back in the days, listen to me carefully, okay? I'm trying to give an idea of what DevOps looks like. Back in the days when Amazon was having its e-commerce website. In fact, today as well, we are using it extensively. But I'm just talking about the early days of Amazon. Right. So what used to be there? It was an e-commerce website for sure. Okay. And you see, what happened back then was the application code, right? I mean, you see the e-commerce website that you see for Amazon, right? It has multiple services involved, or multiple things involved in it, right? For example, there is a functionality within that which is taking care of, let us say, a searching functionality. I want to search upon it. Let us say I get the top 10 search results when I click on the search for that, something like that, isn't it? The searching functionality. Then there is another functionality, for example, which is attached to it is, let us say, being able to put it to the cart. Okay, the cart application within that, isn't it? Then let us say there is another functionality to the e-commerce giant that that is allowing me to kind of, I was putting it into cart. Let it allowing me to kind of go for the shipping of it or billing purpose. Let us say billing purpose. So it will be asking me for my information of my credit card, my debit card, or how do I want to pay for it and all of that. Again, an entirely different service in there. Again, in that, there is, again, let us say, further process, which is for shipping purpose. You may have to tell it, right? What exactly is your address and everything. Right? And such, there are many more functions to it. Okay? I'm just calling out few of them. But you will have many more sort of features that are embedded in your e-commerce website. Now, why I'm drawing it like this, just try to understand, is this is the way the code of Amazon was written earlier. The code of the website was written earlier. Exactly like this. A single code as a whole, a single code as a whole. Okay, wherein all the functionalities, all the services, they were so much tightly coupled together. Try to understand, tightly coupled. For example, let us say there is a database that is used for users. Again, the same database was used for card. The same database was used for their shipping and billing and all. So there was so much tight coupling that used to be there while the application code was written. And in fact, the code was written like this. It was written as a single file as a whole. Okay, the code was written and it was a big code of the entire Amazon website. It was a huge code. It was written literally from, it was written from scratch and until the end. Okay, so you see, in that case, no, because you see, the code of A functionality would be here, for B it will be here, for C it will be here, likewise. It was this kind, it was in this way, in fact, it was kind of written back then. And because of that, you see, there was tight coupling in there. And because of this tight coupling, there was an dependency, or as we call it, in fact, in more technical words, interdependency that was there. Interdependency or interdependent, they were all. So you can see the A is interdependent with B, so is A and B is dependent to C, so is C is dependent to D. So because all of these are so much interdependent, it was becoming more and more problematic. Okay. So you see this approach, and this is not just about Amazon. Okay. This is for every other company back then, that they were using this kind of approach for writing down their application codes, where their application codes were written as a single code as a whole. Single code as a whole. So what used to happen, I'll just tell you a bit more in detail, is that as far as writing the code, there used to be a big team of developers, dev team, right? There used to be a big team of developers, okay, where it would have tens, if not hundreds of developers. They used to sit together and kind of create a code like that. Because it was obvious, right? You see, how would you otherwise create a code like that? Even though, let us say I have distributed my code between the developers, like, okay, A functionality you write down, B service I'll write down, C you write, the other person will write down. But still, you'll have to sit together, right? Because they're also interlinked and interconnected. You cannot write down the code of your own without having to consider the other components and other functionalities. And the problem team, can you identify? Now, this is something I want to hear it from you. Do you see the potential problems that can occur if you go with this interdependent and tightly coupled architecture? Can you spot it? I just give you 1 minute to think over. Can you put it into chat box? What exactly do you see to be the problems that you could encounter if you go with this kind of architecture? Let me just see how many of you can come with it. What could be the potential problems of this interdependent architecture if you use it for longer? So team, you see, the problem is, if I have, and as you're very correctly telling me in the chat box, the problem is very, very, very evident here, is that I'll tell you one really big problem. Let us say this component fails for some reason, or there is something wrong with this, or this particular service has failed. You see how many services it is dependent on, or rather, how many services are depending on that. In other way around. You see, if B fails, it can affect A and C. If it affects C, it can affect D. If it affects D, it can affect E and F further. So the thing is like, the failures are catastrophic. And you have already told me that in the chat box. But if at all the failure does occur, it will put your application at the risk of entire crash. At the entire, it will fall down like a palace of cards. So the thing is like, the failures, they are catastrophic. Not just this, the refactoring is again difficult. Refactoring is what? I want to modify a component. Now, can I do that single-handedly? Answer is no. If I go and modify B component, you never know what impact will it have on the C and the A component. Is it? And if it affects C, again, that's a chain reaction. You see, that's kind of starts up. Isn't it? Not only refactoring, scaling. For example, if I want to scale out or scale in my component, for example, I want to increase the capacity of my service. Again, I have to check on the other components to see it is not affecting their performance, their functionality. Right. And the thing is like, upgrades, scaling, modifications, these are not so straightforward. Refactoring and eventually what it did, no team, try to understand, this is the most important point. Eventually what it resulted into was that because they were, and I want your confirmation on that with this statement, is that you see, because of this particular problems, or because of the architecture, the kind of architecture we have, it used to take huge time to kind of upgrade your application. Huge time. And which is obvious, right? I'll write that in a more technical language. Long deployment cycles, or long development cycles, we can say. Right. Wherein it is going to take a lot of time to upgrade your application later on. Because if you're upgrading, let us say B component, you'll have to see the effect of that on the other components. You have to upgrade those as well accordingly. And again, it will be a long process to upgrade even a small feature. Isn't it? So team, while I'll tell you one more aspect of it before I ask you for your confirmation on it, is you see, just like we have a developers team, because there is no option, right? The developers team has to work together as a team to create this job, to create this code. Why? Because they are so interdependent that they cannot design the code individually. They'll have to sit together to work on this code. And again, the same goes for the further part, is that as the developers team has created the code, it will pass down the code to another team, as we discussed, which is operations. People sort of operation experts or operation specialists, which will be taking up that code. Is it breaking now? Really? Now I think it should be fine, right? It did break, is it? Okay. All right. Okay, I'll just change down to my wired network as well in just a minute. Okay, let's just get done with this concept and we'll switch to my wired network. Okay, let us not trust on my Wi-Fi. Okay, I'll go for wired. Okay, so you see, like I was saying earlier, the thing is like, in the early kind of approach that we had, the older approach, it's still breaking, is it? I hope it's fine now. Can you please confirm? It's fine, no? But team, this is important, and this is something where we will come down to our important point, which I'm trying to convey from the DevOps point of view. Okay, I've just checked let me just check. Yes, I'm turned to my wired network already. All right. Okay, I can see different answers, right? It was fine for the many of us, and at times it was not. Anyway, I've changed to wired network already. Anyhow, so again, you see, like I was saying, this is the kind of approach that used to be there back then when we, the Amazon-like companies, the organizations, they used to use the older approach. Now, team, try to just to understand an important concept here, okay, before I go any further. Is here, as you can see, this approach required, now this is important statement, or this is an important concept. This approach required me to have a bunch of developers working together, bunch of operations teams working together, or people working together. And again, there was this problem. You see, developers team used to put the code across operations team. If there was some problem, the operations team used to put the code across developers again. The developers would modify the code again, put the code across the operations team. And this back and forth kind of transaction used to happen very often. And in fact, what happened was, team, in this approach, there was a virtual sort of wall that was kind of had set up between the dev team and operations team, because the developers team, they were not able to understand the expectations of the operations team. The operations team, they were not able to understand the challenges of the developing team. So you see, ultimately, this was causing a lot of inefficiencies. Why? Because both of the teams, they were not in sync with each other. And this is true for every other, you'll see every other model. Okay, may it be waterfall, may it be agile. Yes, there are improvements with agile with that, but still the dev and the ops team, they are still working individually as their own teams, and it was not efficient. Now, team, before I go any further, do you know what this approach is called? Let me just can you give a guess to it? You might have heard it already. What this approach is called, where an application is tightly coupled, considered as a whole, interdependent. Yes. What this approach is called? Exactly. This is called as the monolithic architecture. Exactly. Monolithic architecture. Monolithic architecture is an architecture where you have the services, the individual services, which are tightly coupled together, which are interdependent, which are prone to failures. Prone to, basically, you can see the failures, we are expecting the failures here, because you see, when you have such an interdependency, the things can always go wrong one or the other time. Just a small modification can make it wrong, or rather it can bring in the problem. So this was the monolithic architecture. This is what most of the organizations, most of the teams, they used to use back then. And many of them, they were, you can see the overall inefficiencies already. The failures, the refactoring, the scaling, the long development cycles, these were some of the big issues. And beyond that, the development and the operations team, they were not working hand in hand. So again, I'm trying to come down to a particular point, okay, with this concept is, so what happened was really interesting. Is these companies, they adopted a new approach. And the new approach was, instead of having such a tightly coupled architecture. They said, let us just do one thing. Let us just give these interdependent services their own freedom. So now in the next approach that we'll see, now we had individual services. They were given their own independence. They were given their own independence. I've just drawn 4 of them, but it can be any number that you want. And these individual services. Now, you see, it is not like they are entirely independent. Yes, they have some communication going on between them, because ultimately at the end of the day, they are working as an application as a whole, right? So yes, they are not entirely independent. They are working as an application as a whole. That we do agree. But ultimately, you see, the problem that we earlier had, like, they were so interdependent that they did not have any individual existence of their own. The failures, the refactoring, the scaling, and the development cycles were so long because of that. That is something that is catered here. That is something that is handled here well. How? Is now you can see in this architecture or this approach, because those services are independent now, you can see the failures, they no longer affect, because if at all one component fails, it will not affect the other component. The refactoring now is possible because I can modify a particular component without having to worry about the other. The scaling as well is obviously possible because I don't have to worry about the other components. They're independent now. The long development cycles, they no longer are there. Why? Because if I want to carry out an upgrade of a particular component, I don't have to wait for other components as such. I can do it individually for my service. For example, let us say for Facebook, you're carrying out an upgrade on chat functionality. You don't have to worry about the other functionalities. Right? And team, this approach, as you might know, what is it called? I think many of you have already told in the chat box what this approach is referred to as. It's called as, what do we call it? Yes, guesses? It's called, starts with M. Exactly. Microservices architecture. Microservices, individual microservices, they are working as an application as a whole. Now, team, I'm going to tell you something really, really interesting here. Now I have a question for you. Okay, and let's just see how many of you can think around it. So if you remember, I told you in the monolithic architecture, we did not have any option other than working as an entire team as a whole, because the application was entire as a whole, right? So we had to work for the team as a whole, for let us say for developers and operations. Do you see any optimization possible there? Do you see any reorg possible there now? The question is, do we really now require, or do we really now need the developers to work together like earlier? Can we give them the independence that our services have got? Can we? Shall we? Exactly. So here comes the best part. Here, now what we can do is we can assign individual developer to individual microservice. right? So what we can have now is we can have individual developer taking care of individual microservice. It is not like earlier, because in traditional or monolithic, it was not possible in the first place, because you could not create the code individually. But now it's possible, right? Because they are now interdependent. They are now independent, not interdependent. They are now independent. Almost. I'll just put a star there for independent because they're not fully independent. But yeah, almost. Minimal transactions are there, but not to the extent it was earlier. Now, I'll go one step further. The one step further is not only I can have one developer per microservice, I can attach what? I can have one ops person per microservice. We can do this, right? Team, what do you think? We will have an entire life cycle of individual microservice wherein each microservice will have a team comprised of you can see, I'll just use a different color pen, a team comprised of a developer and an ops person. Isn't it? A team which is unlike earlier. Unlike what? Unlike what was happening earlier. Earlier, we used to have an entire development team as a whole, but that's not the case now. Now we are having a team which is comprised of a developer and an ops person. And team, in real sense, this is what DevOps is. DevOps is not asking developer to work together with ops and just resolve the kind of conflicts that you had. It's not like that. It is literally bringing them together to work together on a particular microservice like this. In fact, microservice is the foundation of DevOps. That's why I kind of shown you how DevOps actually looks like in a real world, or in a more convoluted way. I've shown you this, I know, but it was required so that you will understand the real essence of DevOps. So DevOps in real terms is this. We're asking the dev to work with the ops as a team, which was not happening earlier in any of the model, whether it be waterfall, let it be your agile or whatever. This was never happening. You were not having one developer, one ops person taking care of one microservice. And this is what team we call it DevOps. Right? Dev and ops in real terms working together without it. So you'll see there are some cons to it, there are some advantages, there are many advantages, there are a few cons to it, we'll see that. But at least for now, I hope you have understood what's in reality or what's in real sense a DevOps word, or where this DevOps word comes from. Is it, team? Can you please confirm quickly in the chat box now? Have you understood what this DevOps word, I mean, how important this word is? And what is the background? What is the context behind this word? In fact, you see, I've seen, I mean, I could have directly told you, right? Yes, DevOps is Dev and Ops working together. But how? Anyhow, they were working together. It was in waterfall, even it was in, let us say, agile. They were working together, no? But not like a team as a whole, right? And you see, again, this DevOps has got kind of, what I can say, the meaning of that has got evolved over the time. It has been adapted. It has been kind of taken up the way the organizations they felt well. So this is not the only definition of DevOps. We'll see that how organizations have taken it up, kind of considering their own convenience. But in real terms, this is what DevOps should be, wherein you're having a dev and the ops which are working hand in hand to solve a particular problem. Or not a particular problem, rather, I would say they are taking care of individual microservice. Okay, now team, one thing I want you to be very, very clear with right here, right now, is if you see this particular process, no code, build, test, provision, deploy, and monitor. In monolithic, there was a single pipeline for that. This is what we call to be the pipeline. Code, build, test, provision, deploy, monitor. This we call to be the pipeline. So there was a single pipeline earlier for monolithic, but a big difference with the microservices is that every microservice will have its own pipeline. That's the beauty of it. Try to understand. Okay, every microservice will have its own pipeline. Okay. Now I have a question here I can see. So no shared data or replication of data for microservices. For example, data like name, company. You see, there is a sharing of your data. And that's what I'm trying to convey. You see, let me give you a real-time example that will give you an overall idea. In the same example of Amazon's website, no? Now, if you're using cart of Amazon website, the cart feature of Amazon website will require a different kind of database. For example, we use the DynamoDB, as we call it from within AWS. Okay, but let us say if you are trying to, if you're using the search function, or if you're using the billing or a shipping functionality, there we use a RDS-like database, which is more, or which is better for transactional kind of operations, right? So the real essence or the real value of microservices is that it will isolate your services as much as possible. Does that mean you don't have interaction at all? No, I've told you already that yes, there will be interaction because they are working as a whole. Yes, the input, the output will be passed from one service to the other, which has to be used across, because you see the card and shipping and billing cannot be entirely individual, right? You will have a link between all of them. Only after one service is done, it will go to the other service with the relevant information. So the answer is yes, there is a shared data. You will have to have a shared data, but the data will be minimal. You won't have a single point of failure. You won't have that kind of interdependency that earlier we used to have. Okay, that's exactly what is different, as you'll see with DevOps. Yes, exactly. From as soon as you're pushing the code to the repositories, from there on, the operations team will take it on and make sure to make sure to deliver it to the market. All right, team. So I hope this particular part is clear. Now, can you identify? You can see these particular problems are what we have just now resolved. This is important. You see, these problems we have just now resolved. So these problems are no longer there in microservices. One few advantages further are that now we have brought in the sense of accountability. We have now the sense of accountability in our applications or in our operations. How? So now you can see this developer is responsible for this microservice. Now this is accountability. Okay. So anything going wrong for it, the developer will be responsible for it. It was not the case with the monolithic because the entire application was developed as a whole. So you could blame other person. That's not the case here. Okay. You'll be responsible for that entire microservice. So is the operations person. So accountability that gets in, and so is the ownership. Ownership how? So you will own that microservice. Anything going good for it will be your credit. Anything going bad for it, you will be something that will be asked upon. It will be something that will be checked with. Isn't it? So how the microservices communicate together? Always HTTP, microservice. No, you see, microservices, how they communicate together, that's an entirely altogether different discussion, because you see, you'll have to have a workflow that will create so that they can work hand in hand, so that they can talk to each other. Okay, there are different ways of doing that. Depends on what kind of services you are using. So if you're using containers, you'll have different ways of talking to each other. If you're having EC2, if you're having which server, yes, API based. Everything is API based. So that's normal. But depending on the kind of workflow that you have, how would they interact? For example, if I talk from AWS point of view, you will see there is a service called as step functions, which you can use for orchestrating across the different microservices. So, I mean, there are many options to that depending on what kind of orchestration you are looking at. But yes, it is required that this orchestration is done. You can do it manually in your code already, or you can use services from within the cloud platform to be able to do that. Okay. So team, yeah, can you please confirm if it is understood until now, the concept of DevOps, before we can deep dive into the roles and the responsibilities and all of that. Don't worry, we'll be looking at that in just some time, but I believe it's a good time to take up a break, right? Many of us are asking for it. What do you think? Let's just go for the break right away. The midway break, I would say rather. Okay, and with that break, or after that break, we will continue our discussion for the rest of the. No, that's what will be. No, advantages. That's what I told. No, advantages are like the disadvantages of monolithic. They are all catered. And secondly, accountability and ownership. These are the two advantages that your organizations will have. Third advantage, you will have collaboration and communication across dev and ops. So you'll have better or efficient processes that are being developed. Third, you will see with the microservices, now you have fast life cycles or fast software development life cycles. Okay. So what it does is you'll have the upgrades very quick. In fact, it is told that before DevOps, it used to be like one upgrade in 3 months or something. But with DevOps, now we have brought it down to 5 upgrades in a day. That is what DevOps documentation does talk about. Okay. Yes. All right. Okay. So just get going, team. Let's just have a look at the technical definitions and understanding of the concept that we have already seen. So this will be more of a summarization of what we have already seen, but in a more technical way, okay, which will help you go into the interviews, the exams, and be able to upskill yourself. You should be knowing it in more technical terms. So let's just see what do I mean by that. So introduction to DevOps. Okay, that's what we were having earlier. Okay, now this is. So what is DevOps? Why DevOps? What is not DevOps? Objective of DevOps? Business value of DevOps? Let's just have a look at all of these aspects. Okay, and it's important for all of us to understand them before we can actually deep dive into the principles and the foundations of that. So as you can see, if I talk about what is DevOps, this is the first question that we have. Now, just to put it into more formal words, okay, what we can say is DevOps. Let me just make use of the pen. DevOps is like, it is the union. You can see union. Right. Am I not audible? Just a second. I am, right? All right. All right. Okay. Sorry. Okay, so I think. Okay, so like I was saying, team, DevOps is what? DevOps is a union of people, process, and the products to enable continuous delivery of value to your end users. Now, you see there are many terms to it, as you can observe here. Okay. It's for the people. I think I am missing out on the pane. All right. Okay, people, process, and products. Okay. Now, union of people, why is it called so? Because if you remember, that's what was the real reason the DevOps got into picture, is we wanted the union of dev and ops, right? And that's where the people, we wanted to bring them together to onboard the talents, right? So you see, the real motive behind DevOps was to bring in the talents together and make them work together. That's what the more important part was. Processes, the union of processes, because you see, depending on the collaboration that you're doing between the people, we will choose the appropriate process and the products as well to enable continuous delivery of value to our end users. Now, continuous delivery is basically a way. In fact, let me just show you that on the screen as well. What do I mean by that? So when I say continuous delivery, there are a few concepts, team, I would really like you to be aware of, because this is something that will be tested on in the exam as well. Okay. Now, let me just use this diagram rather, the same like we used before. Now, in this pipeline, this software development life cycle, as we called it, no, there are a few more concepts that you should be aware of before going into DevOps. One of which is this process, this first three blocks. These three blocks: the code, the build, the test. Okay, what happens here? If you remember, I told you that we will have a developer push the code into the code repository. The code should automatically trigger the build, and the test should be carried out there. But what if, now I'm assuming here that the tests were successful. Okay, and that's why the process moved for provisioning and deployment and monitoring. That's what we assumed, that okay, the tests were successful. But what if the tests are not successful? Then ideally from here, your developer should be notified that, okay, developer, there is something wrong with the code, please fix that. Again, the developer will push the code. Again, this entire process will follow. So this loop, no team, this entire loop between code, build, test, developer, code, build, test, developer, code, build, test, developer. This entire loop is referred to with a particular term. We call it continuous integration. This is one term that will come across very often. Continuous integration. Now, continuous integration is that concept from within DevOps, which is indicating a continuous testing of your code until it satisfies all the compliance requirements and restrictions, or all the sort of tests. Right. So this loop, you see, the loop between developer, code, build, test, this loop will continue until what? Until we get the best quality code at the end of the test. Otherwise, this loop is bound to continue in the same fashion. Okay, and that's where, team, remember, it's called as continuous integration. Okay. Now, another term, another new term, another important term I would like to bring to your notice is, let me just make use of some shapes there. Okay. Now, this process, listen to me carefully again, this process. Rather, I would draw it a bit lower, because I want to show something else before that. So this process, team, just try to understand. This entire process, which is going in from the code to build, to test, to provision, to deploy and monitoring, this entire process, remember, if it happens automatically or in an automated fashion, then this is referred to as continuous deployment. What does it mean? Remember, continuous deployment is nothing but when you have the entire process from code to build, to test, to provision, to deploy, to monitoring, if all of that is happening without any manual intervention, in a fully automated way, then it is referred to as continuous deployment. Two really, really important terms. We call it CI, and this is CD. Okay. But there is a small catch here. In that, yes, I told you this is continuous deployment, but there is another variation of it. under which what happens, I'll tell you. Okay, is until this point, you will have full automation, just like continuous deployment. But there is something different happens here, is that at this phase, generally, we will bring in some sort of manual intervention. Okay, and then again, the process will go forth and complete this entire pipeline. So if you have such manual approval or manual intervention, generally this happens right before the pre-production. Okay, where you want to manually just verify once that, okay, if the process should move ahead or not. And if you have such manual approval, this team, remember, this is referred to as continuous delivery. Okay, so remember this carefully. This is a very tricky question that can come up. This as well is referred to as CD. Continuous deployment is as well referred to as CD. But there is a significant difference between the two. While continuous delivery is where you may have a manual approval involved, some sort of manual intervention involved, whereas in continuous deployment, we don't have any. It will be a it will be a fully automated deployment that will happen, going in from code to build, to test, to provision, to deploy, and to monitor. Is it clear, team? Can you please confirm? CI/CD concept. This is why it is called as CI/CD pipeline. Now, what is the meaning of D? It will depend on what kind of pipeline you are looking at. CI/CD pipeline. This entire pipeline, you can see this is a pipeline sort of. That's why it is called as CI/CD pipeline. Can you please confirm the concepts are clear? Continuous integration, continuous delivery, and continuous deployment. Is it clear, team? I hope you will never get confused again, ever again, with these three terms. How are others? No, you see, don't get confused. Continuous deployment and delivery, both of them, the only difference between them is that whether it is automated or not, whether the entire process is automated or not. And I'll tell you the reason behind it. At times now, if you are working with some critical application, a very critical application under which you cannot afford to take down that application anyhow. In that case, companies, they do what? They will use continuous delivery, wherein they will always just have a quick manual look at your deployment that's going into production before it is approved. Okay, so as much as we rely nowadays and as much as we trust the machines and the systems and the automations, some critical applications, at times we require the manual approval in place, so that we will just manually check it once before it goes into production. Okay. Yes. I'll be sharing this whiteboard with all of you. Okay, don't worry. This whiteboard, I'll be sharing it with you at the end of the session. Okay, it will be shared across on your WhatsApp. Whiteboard entirely. I've given an example, if you remember. Code is a place where we have repositories like Git and GitHub. For build and test, we have Jenkins. For provisioning, I've told you it is Terraform and CloudFormation like services. For deployment, you can use the code deploy or Jenkins like service already. And monitoring, you can use services like CloudWatch over there. No, that's what you see. That's the trick here. Why is it called as continuous deployment? Because this is not a one-time process. We do this over and over and over and over again. Every time you want to do a change, developer will modify the code, and every time this process will kind of begin from scratch. In fact, every time the deployment would occur. So it's a continuous. In fact, continuous integration, why it is called so? Because you see, unless and until that particular code is satisfying the requirements and the tests and the compliance, it will never move ahead with the process. Okay, so that's why the term continuous is something that's been mentioned there. Okay, all right, let's just go ahead, team, and have a look at what we were looking earlier. Okay, so if I just go back here, introduction to DevOps is what we were looking at, and among them we were looking at what is DevOps, right? So like I was saying, just a second. What's wrong with it? That's what I was saying. Okay, so you see, DevOps, as we discussed, it's a union, as we discussed, of people, process, and products, right? Now, DevOps, again, you see, it is not just about automating a pipeline so we can quickly deliver the software. Our goal is to deliver the value. So it is not just about automation, it is as well about delivering the value to the user, just making sure that, again, I'll tell you, team, really one important aspect of DevOps. No, even though you see, even though you're changing it on 1 month or even quarterly as well, it doesn't matter. You have to have such a process involved as a part of it. You don't want to take care of each and every block later on, even after 1 month or 3 months. So believe me, you have to have such an automation in place if you are looking for an optimized and efficient solution for carrying out the deployments. If you go manually, believe me, it's a big headache. You would never want that if you're working or if you're actually working with a real world application. It will be a mess. It will be a disaster if you try to work with these services individually. Believe me, I mean, in fact, I could not show you this because this is not specifically for a particular cloud as such, but I'll show you with the pipelines that we'll set up why it is so important and how we should not be doing it manually. I'll show you that, okay, with example and demonstration. Now listen to me, Kim. If the value only reaches the dev and QA environments, but it's held up before reaching production, where it can be realized by our end users, we are still failing again. Now, having said, why DevOps? Okay, this is again an important question. Why at all we want DevOps, isn't it? Let me just give me a second. I'm sharing the screen back again. I think that annotation got stuck over there somehow. All right. So like I was saying, if I just go back to what we were discussing a while back, is as you see, why DevOps? So you see, we've just now seen DevOps is basically working dev and ops together, right? And it's all about increasing the velocity and the pace with which the deployments are carried out. Why DevOps? There are 4 main reasons why DevOps is growing and increasing, and it is increasing in demand. Why at all it's so? The very first thing is your competitor is already doing that. Okay, because that's what, in fact, what happens with any train, right? You'll see by the time that everyone was using monolithic, everyone was using it. And by the time people started moving towards DevOps for the sheer advantages, and not even DevOps, it brought in a big change in the strategies as well. Let us say microservices, containers, and collaboration and communication, and all of those aspects got in. DevOps, that's why, no, team, remember, DevOps is not a tool. It's not a service. Okay, remember, it's more of a culture. Because not only that you are adopting new tools and services, but it is as well a mindset that is shifting. Yesterday, you were working with 4 of your development colleagues, and tomorrow you are literally working with an entirely new team of ops people. So it is like that. You see, there are 4 reasons, like I was just discussing. Your competitor is already using it. Increase in velocity, that's really important, because if you remember, I've told you in the monolithic architectures, because the dev and the ops were not working hand in hand, it was creating, or it was having long development life cycles, or like long development cycles, or development cycles are. Okay, and that's what we are trying to kind of make better in a way of using DevOps, is that we are able to increase the velocity of operation or velocity of deployment. Okay. Reduce downtime. Downtime is reduced. Why? Because you see, if at all one particular component of the DevOps pipeline, or let me just put it across like this. So as I was saying, that even if one component, let us say you think of it like a component like A. Okay. Now what will happen with that is, even if that component do fail, it will not hamper the other components around. And that's why the overall downtime to fix it would as well be reduced. And reduce the human error, because you see, DevOps is all talking about the automation everywhere. So you should not be involving, you should not be having a manual intervention as much. And that's where it is suggesting you to reduce the human errors as much as possible. And it will be evident. I mean, it will be always be there that your human errors will be reduced, because there is lesser human intervention. Now, as far as sorry, historically, if you have a look at the different models that have been used, okay, maybe waterfall model, maybe agile model all the time, the innovation, the rigorous processes that we were working through, okay, they were not so efficient for the very reason I've told you, is the lack of communication over there. Even the same goes with agile or agile model as such as well. But agile, you see, it is a better approach than what we had for waterfall. But ultimately, this DevOps architecture, or this DevOps culture, okay, this is the particular word that you should be using, is what has taken down those limitations, what has made sure that those shortcomings are all taken care of, and the business value is what is being provided. Now that we know what DevOps is, let us just see what is not a DevOps. It's very important to realize that DevOps is not a product, just like I've told you multiple times before. Okay, don't misunderstand that for the service, nor a tool. No. It's not something that you can adopt overnight. So again, that is one big misconception that people have. Right? Yesterday they were not on DevOps and today they are. It's not like that. It doesn't work like that. You cannot change yourself overnight onto DevOps, because bringing in DevOps has its own features and its tools and its best practices that you'll have to incorporate. And it's not so simple. Not only that you are going to change the overall portfolio of your organization, but as well, you will see there is a mindset that you'll have to take care of, that will shift. Okay. It's not a team again. So it's not, DevOps is not again about just a team. So I told you that yes, in a DevOps, we're having Dev and Ops working together, but it's not about that only. Yes, it's a part of that. It's not just about that. It is the more or for the base of DevOps is more about the communication, the collaboration, the automation, as we discussed earlier. Right, so it is the best practices. It is the approach that we are bringing in, not a specific tool or a team, not a title or designation again, not just automation or ISC. So yes, these are individual sort of, so it is like an elephant, right? So it's like a big elephant like that. It's not just a trunk. It's not just the leg. It's not just the tail. It's a big elephant in a sense. You cannot just think of it individually in a discrete way like that. So DevOps is people following a process enabled by products to deliver the values. Now, one thing I'll tell you with this statement is that in DevOps culture, okay, let me just put that across on whiteboard. Is in DevOps culture, there is a saying that people over process over tool. Okay, so it is basically emphasizing upon what is most important in DevOps culture. So as you can see from the foundational principles, in DevOps, it is always, or it has always been a people or customer-centric service or customer-centric culture. Wherein people are always preferred, or the experience is always preferred over, let us say, a process that might seem better in a particular situation. So you see, if at all there is a process to be chosen, the experience in the organization, the experience in your workforce is what will matter most, and not the process. Process is something that can be a guide for one or the other process, but ultimately it is all about the people or the experience that you have with people. The same goes with process over the tools. So if you have multiple tools, which tool to choose will be indicated, which will be sort of dictated by the process. So you see, these three things, they in fact kind of put DevOps in a nutshell, is how DevOps looks at the overall culture. The culture is having least, if I just want to put it into different words, it is having least sort of importance to tools, more towards process, and most importance to the people working. So it is a people-centric, never forget that. So on the same line, you see objectives of DevOps. What are the core objectives of DevOps? So you see, as a part of that, DevOps goals is, if you remember, we discussed concept of microservices, right? So with the microservices, we discussed that it is not about a big application as a whole, but rather it's about the smaller microservices. And that's why microservices are considered to be foundational building block of, or the building blocks of DevOps. Right. So first goal is you should be going smaller and more frequent releases. So if you remember, I told you earlier it used to be one release in 3 months. Now it is 5 releases a day. It's what it has come down to. Right. Next, reduce efforts and risks. So if you see, if you have single point of contact, you are bound to get some or the other error. More decentralized your application, lesser the chances of having such single points of failures. So reduced efforts and risks because of such decentralized architectures that you get from within your DevOps. Reduced cost of product iterations and delays, because you see, now that people are working individually across the services and tools and making use of the appropriate services, it will be a reduced cost, because at times I've seen what happens, in the cloud world. I've seen clients, they very much tend to use the things that they own. For example, they have an on-premises database. They are really, really sort of pushing the developers that, okay, please use the existing one. We don't want to purchase another one, or we don't want to take on another service. So that's where the reduced cost of product iteration will come into picture, because at times what happens is, just because of the small benefit or the very near future benefit, we kind of overlook at the longer benefit or the larger picture. So what happens is, if you're using specific services as dictated by DevOps, rather than having centralized approach, then in the long run, you'll see that you are going to cut down on a lot of cost, because you're utilizing the resources to its fullest, which might not be the case always with the traditional approaches. A culture of communication and so this is, again, I've told you, this is the basics of DevOps, wherein we wanted to bridge that gap between Dev and the Ops. And that's why it is a culture of communication collaboration. Let it be by means of your team formation, or working as a team to solve, or working as a team to accommodate the entire pipeline. Right. So in many ways, it's all about bridging, or it's all about setting up a communication and collaboration, sort of an environment that does have these best practices. Consistency and speed through automation. So I've told you already, one of the foundational principles of DevOps is to automate. And when you do the automation, you are bound to get the speed along with. Now, what are the things that it benefits in, again, other than the goals that we have set up? Yes, the time to market is what it caters well. Because again, if you remember the same thing, one release in 5 months or 3 months to 5 releases a day. Integration with the business, responsiveness, quick responsiveness, code and deployment quality. Why? Because continuous integration, continuous deployment is making sure of that. Productivity is increased. Why? Because your users are accountable, your employees are accountable. They will be focusing on individual tasks rather than an entire application as a whole. And visibility and agility as well. That comes into picture because of the DevOps. In fact, we'll see in the monitoring module as well how the different monitoring tools can be used along with. Okay, now business value of DevOps. Now, DevOps can be used in many ways, rather. But these are some of the 7 reasons that you can at least remember in order to understand what is a business use case for DevOps. Now, as you see, improved speed to market. Now, this is something that we have discussed a while back already. Continuous integration and delivery. So this is, even if we have discussed that on the slide before, right, that the continuous delivery is what makes sure, or it's what is important, continuous delivery and continuous integration, so that we can set up a pipeline which will be fully automated as much as possible. Third, higher quality, few failures, and high stability. Why? Because yes, definitely and obviously, there will be fewer failures, because now we don't have an interdependent architecture anymore. We are having a microservices architecture, and yes, we'll have fewer failures, and we'll have a more stable code. Then innovation and creativity. Now, this is one aspect that I did not discuss earlier, if you remember, is if you're not spending a lot of time on, or if you don't have to spend a lot of time on working through the complexities of monolithic architecture, if you're working with an individual service or individual component or individual microservice, then you'll get enough time and you'll get enough freedom to innovate and bring in the creativity. Because you see, earlier it was not possible. With monolithic, neither the innovation nor the creativity was possible because the application was considered as a whole, right, and not individually. So that is something that was not so much possible. Then increased employee engagement and job satisfaction, which is for obvious, you see, because now we don't have siloed teams. We have working, active, proactive teams, rather we will say, because now individual microservices are assigned to individual people. They will be entirely responsible for that. Again, the same thing like I just mentioned, breaking out the silos is what has been its big advantage. Okay, so what was happening is, let's say the dev and the ops, those were two big silos back then. They were working together as a team as a whole, but not together across the teams. And that's what is kind of brought down here in terms of being able to bring down those silos and being able to work together as in collaboration. Finally, you see resource and cost reduction. In fact, if you're using the managed services now, as we use it into cloud platforms, you will see that in the longer run, as you go with the advanced services and features, and as much as automation as you could, and you are going to use it over there, isn't it? It's bound to reduce your cost and give you better performance in the long run. The business value, just like we discussed a while back, the companies with high IT performance are twice as likely to exceed their goals: profitability, market share, productivity. Okay. And you see, this is what, or who is doing the DevOps? Who is up to it, or who is after it? So, or who is using it in simpler words? So if you see the giants like Amazon, we have Netflix, we have 𝐻𝐶, we have Facebook. As big as that, they are using a DevOps. Entertainment, you see Disney, Sony Pictures, Apple, Lego, Unilever. See, you name the company and it's over there. So you see, most of the big brands, big companies, they are using the DevOps for their own operations. That's why you see the many openings that you see nowadays, they are mainly coming across as for the DevOps roles. Okay, next is we are going to discuss what are the DevOps principles. Now, this is particularly something we have been discussing all along. Okay, now we'll see what are those in the very next session. Okay, yeah, not session, rather in the very next slides. Okay, that we have right after this. Okay. Now let's just see what principles are we talking about. Just a second, let me just see for it. Just give me a minute.
All right. Okay, I'm just downloading that. So that will be. I'm opening the screen up. I'm sharing the screen. Just give me a minute. All right. I was just making sure it's ready for. So DevOps principles. Let's just have a look at those now. Okay, what are the principles with which this particular DevOps culture does go for them? Now you see, as far as the module for this, the agenda for this module is concerned, we're going to discuss the principles of DevOps and calendar model in DevOps. Talking about the principles of DevOps itself. Okay, you see, there are three ways, in fact, as we call them. Okay, of how that's been tackled. One is where we understand and increase the flow of the work. Second is where we create the short feedback loops that enables the continuous improvement. Okay. And third is where we're having continuous experimentation and learning just to be able to innovate, just to be able to kind of create new things upon it. Right. So flow, understand and increase the flow of the work. That's important. First one. Secondly, we have to, like I just mentioned, the short feedback loops will help us in continuously improving upon the things that we are already not good with. And third way, increasing or continuous experimentation and learning. So you can see, in this, you can create a culture as it's been told here for experimenting, taking risks, understanding and repeating. And you see, this is something that's allowed, or this is something that's possible on cloud a lot. Because you have a wide variety of resources that you can avail for yourself. Okay. And you can experiment upon it for creating something innovative out of it. Okay, now again, DevOps in three ways, just like we discussed a while back. Okay, so the first way is system thinking. For example, second way, amplify the feedback loops. Okay, and third one is culture of continuous experimentation. Okay, so you see, the first, let's just discuss that in detail now. Okay, these three we are just going to look at the dev and the ops. Okay, and we are looking at the three important aspects of DevOps, or three ways how we inculcate that. Now, the bottom line is, you can see the goal of the first way is what? I just use the data pointer. The goal of the first way is what? Is to have workflow quickly from left to right. Now, you have to understand the workflow, how it's going in the DevOps. You have to increase the workflow as much as possible in it. You should never be passing a known defect downstream. So again, it is important in DevOps that you should be curtailing, you should be mitigating the issues and the bugs and the problems upfront. Should not be taking it down, because as it goes down, as it moves further, it will be really difficult to cater that and kind of be able to handle that. Never allow local optimization to cause global degradation. So you see, there is no shortcut. You'll have to make sure that the ultimate goal that we have is to have a globally accessible application. So you cannot basically manipulate something locally and expect it to go better on a global scale. Okay, and so basically local manipulations, they do not work well. You should be considering it. You should be considering the bigger picture of the application, and accordingly you should be doing that. And achieving profound understanding of the entire system is something that you should be having under the ways to adopt DevOps. Second, feedbacks are so important. You see, I've told you multiple times before that DevOps is a customer-centric culture, not a service, not a tool, not a method. It's a culture. And this culture is customer-centric. The feedbacks, they do matter a lot. So that's why you have to understand and respond to the needs of all the customers, both internal and even if they are external. So that's what will make it better, because that's what AWS or even the Azure or the GCP like platforms, they are, and these are big giants, they believe in. Is because on the cloud platforms, you have the option to experiment as and when required. But the ultimate goal should always be the customer satisfaction. You should always make sure that your end user is not suffering and the end user is getting what they're expecting. That's where your service, your applications, they will be popular over the time. Shorten and amplify all the feedback loops. So as short the feedback loops would be, better and granular feedbacks you will get. Longer the feedback loops, it will be time consuming and as well may not consider all the sample size. So better, you should be going for short feedback loops to get an idea by extrapolating that. Create and embed the knowledge as and when required and as and when possible. But again, the bottom line is the goal of the second way is to shorten and amplify right to left feedback loops so necessary corrections can be continually made. Okay, now examples of the feedback loops can be automated testing. You can carry it out. Dashboards you may have to be able to look at in an interactive way. Production logs you can observe. Process measurements, you can do it by means of different services available. Postmortems of your application can help you in that regard. Change, incident, problem, and knowledge management data. So basically, ultimately, you see, feedback loop is just making sure that what you have deployed, what is running, whether it is worth it, whether there is a scope of optimization. Isn't it that those all aspects are being considered there. And third and the final way of DevOps, as you can see, is continual experimentation and learning. Now, this is something that we are taking it from point number 2 as well. So the third way encourages a culture that fosters two things: continual experimentation and taking risks. So it is fine. AWS is as well pushing you to take some risks. Yes, in a calculated way, rather. Okay, but you can take the risk because you have the option to innovate out of your resources and create a history out of it. Right. So continual experimentation, creativity, taking risks, these habits will matter. These habits will kind of make sure that we can bring in the creativity and the innovation in your application. So under the third way, we are allocating the time for improvement of daily work. So you'll be continuously observing, optimizing the daily work to see how the optimization can as well be carried out. Create rituals that reward the team for taking risks. So again, this is more of like convincing your team, or rather what we can say in a better word, influencing your team so that they can take more and more risks. Again, the calculated ones for sure. And go about bringing in the innovation and automation. Both of them go hand in hand. Introduce faults in your system to in your system to increase the resilience. So at times it is better. In fact, AWS does allow you to kind of do this fault checking or inducing the faults as well. Again, there are some conditions to that, how you should be doing it and to what extent and everything. But ultimately, remember, this allows us to make sure that those faults is something that we'll learn from. Plan time for safe experimentation and innovation. Again, that's important. So the third way is where it encourages a culture that fosters two things: continual experimentation, taking risk, as we discussed. Now, moving further, practicing for the failure response. No, it's not like that. It's not like that. Again, it's not just about while your competitors are doing it, you should be doing it. There is a trend at times. What happens, I'll tell you, is because over the years, you see, the companies, they were stuck with that micro or the monolithic architectures. No? They wanted a better solution. Just like you see, Apple kind of brings in a product. Okay, and the companies, they do follow to create a copy of that immediately. Now, it's not about being stupid. At times, yes, the feature might as well be good. Yes, exactly. That is the point over there. Yes, the competitors are doing it. Again, that's what I'm saying is at times what happens is like when a particular leader is doing or a particular renowned company is doing something, you will check whether it is actually good enough to go with for your applications as well. And that's what is happening. That's what I was giving an example of is at times, you see, if there is a better approach, go for it. Isn't it? I mean, while you have the approach that is not doing any good. Oh, exactly. It is the flow with the industry led. Exactly, Kumar. Exactly. Totally. Isn't it? So, having said, now you see, that's what the problem is. As and when, and this is how the overall DevOps has evolved over the time. That's what I'm trying to convey again. Okay, while through the slides, so these are more technical slides, I know. It can become a really bit boring afterwards. Don't worry. This is the only place where we will be using slides. Okay, literally from tomorrow on, we'll never have slides for any session. Why I'm walking you through these slides is that it is at times better to get a technical understanding with the real time, or rather we tend to understand the things more in our language, and at times it becomes difficult when you're going for interviews and kind of expressing your views there. No, it doesn't sound so technical. So it is at times it is better to have some technical thing or technical words in your dictionary just to kind of answer your questions and go for interviews and be able to crack it. And that's why I'm walking you through these couple of slides, couple of modules. Just even today only. Tomorrow on, it will be all whiteboard and console and demos. But it's worth, believe me, because these aspects, these technical words, they put a lot of information in a concise way. And it is really, really sort of important to be able to express it in this way. Okay. Anyway, practicing for failure responses. So the chaos monkey concept was first adopted by Netflix as a service. You can check out it later on. Okay, this is what chaos monkey is. I don't want to kind of put it across right now. It will be an entirely entirely different discussion altogether. Okay, it will be intentionally inducing the error or inducing the issue problem in the environment. Netflix, by the way, uses AWS, so I can tell you a lot about that. But anyway, that's not the point of discussion today. But you do, I mean, I highly recommend you. Okay, do check it later on today. What is Chaos Monkey concept as given by or as being used by Netflix to kind of see for the resilience and the robustness of the overall architecture. It's really so. It is better at times to induce the errors to see how better your architectures are. On the same line, response to attacks. So attacks, you should not be you should not be waiting for the external attacks, right? Because the person who is doing that external attack may not sympathize you. Okay, so it is better to induce the errors and attacks on your end to simulate what would happen and how you would respond to it. Right. So it's really okay. Let me just look through this question. Look for governance. Dev1 takes a library. Dev2 deploys similar for himself. For example, for database connection, Dev1 likes Python, Dev2 likes Java. So a farm of technologies grows up. How to handle this? Who does this? Look for governance. Dev1 takes library. Dev2 develops similar. No, that's where. I'm telling you this exactly the same thing. Is that it is not about one service or the other. The developer is responsible for end-to-end development of a single component. That's what the beauty of microservices is. I told you, and this I told you by emphasizing it on that. That when I say microservices, no, what happens is individual. Yes, we could hire another one. We'll have to. Exactly, and that's what the real point is. Different microservices are going to use different technologies, and that's why they are created in that way. In fact, that's what the real beauty of microservices are. They are created for using even entirely counterparts of each other at times. Why? Because they are providing you the value of that. They are giving you the performance that you would otherwise not getting. Right. So talking about that again, like I was saying, that yes, as far as you are the DevOps team is concerned, the microservices, if you talk about them specifically, Dev1 and Dev2 individually will be focusing on their own microservices. They have nothing to do with the other microservices. Yes, there will be a minimal transactions between the two, but otherwise they should be entirely working with their own. Yes, again, if you're failing to have, or if at all you're failing into that particular microservice, as I've told you, the team will be responsible for it, and not the entire developers team or neither the entire operations, the individual teams. Okay. That's entirely different sort of word altogether, isn't it? But you see, this Chaos Monkey, it's a really nice concept. How does, for the AWS point of view, how does this inducing does work? It's getting stronger through failure is the basis of anti-fragility. Isn't it? You don't want external attackers to make you strong. Okay. Because you may never know, they might be stronger and you might kind of fail to the victim of it. So you don't want that. Better to induce the errors, experiment upon it, so that if at all a real attack does come in, or if at all a real failure does get in, you should not be hampered. Now, having said Chaos Monkey, in fact, they have mentioned over here, applying tools like Chaos Monkey to apply monitoring, diagnostic, randomization, disruptions to the infrastructure. Endure engineers use automation. Now, this is something I'll highly recommend you to check on later on. Okay, let us not waste time on that. It is really interesting concept of Chaos Monkey of Netflix. Having said, encourage a learning culture. Now, this is important because you see, again, this might seem very theoretical. This might seem very impractical, or not impractical, but more of like philosophical. I know, but believe me, these are the building blocks of DevOps. DevOps was created considering these all aspects, assuming that you are developers, you are operation people, your ops teams, they will be continuously upgrading themselves. In fact, I'll tell you one really funny thing, or rather, I would tell a really interesting thing, rather. Is in the DevOps culture, it is said that the developer, yes, it should be an expert developer, but as well, he should be 80% expert in its own area and 20% in the other person's area. Interesting, right? So let us say, I'll give you an example. Let us say we have a developer and we have an ops person. So developer should be 80% expert in development and 20% should be aware of the operation tasks. Similar goes with the operations expert, is that the operations expert should be expert 80% in the operations activities and 20% in the development as well. This is how the collaboration, communication, learning, upskilling does work as far as the DevOps is concerned. So first of all, you should be encouraging daily learning and knowledge sharing. Create training, skill-based education plans so that your developers, your ops, and your employees, they will upskill themselves, just like you all are right now. Incorporate learning into processes. So you see, that's where now it will become really, really interesting, because in the DevOps, you will have a lot of scope of experimentation and innovation. So more you will learn, more you will understand the practices that, or the different options that are available, you'll be able to incorporate your own systems and your own creativity into picture. You should be using technology to accelerate the learning. Make work education through experimentation, problem solving, and demonstration. So it should not be a traditional learning as such, more interactive. And allow the use of mistakes as a source of learning. That's something, you will see it across DevOps that will be having the mention of that. Mistakes, take them as your first step or take them as your learning. Don't get discouraged by mistakes. They are bound to happen. And make the result of learning visible. Now, this is important. Lesson 2, as far as DevOps is concerned. This is a model, as we call it, CALMR, Calmer as well at times it's called. Okay, this encompasses, now this is important, team, please be aware. This encompasses the 5 major values of going on with DevOps. Now, which are those? So you see, culture, automation, lean, measurement, sharing. We'll see each one of them one by one. What are those values and how do they help us? Now, the portal, Nirmalya, on the portal, you should be able to observe those. Okay, Deepak will be available in just some time. Okay, but ultimately, though, on the same portal that you're using with other courses with, this video should as well be available. Okay, again, at the end of the session, Deepak will be with us and he will talk more through that. Having said, team, DevOps values, culture, automation, lean, measurement, and sharing, as I was saying a while back. No, I'll talk to him. He was there in the beginning of the session. At the end of the session, I'll ask him to join in. Okay, and check for the last session. You see, the thing that I was emphasizing on since morning or since the beginning of our session today is DevOps is a cultural movement, not technological, not methodological, neither from the tools perspective, but rather it's a cultural movement based on human and technical interaction. That too to improve the relationships and results. Having said, these values, they play a very important role in building a DevOps culture in your organization. So DevOps core values, in fact, these are the DevOps values But the core values are cut down to only 4 of them: culture, automation, measurement, and sharing. Okay, lean doesn't come under that. Now, the talk, as we talked about the core values. Okay, so you see, for the DevOps point of view, the core values, if you remember, if you see over here, okay, the culture of shared responsibility, automation of continuous delivery pipeline, lean flow acceleration. In fact, these are the names that have been given out for the values of DevOps. You can see measurement of everything, and recovery enables low risk releases. In fact, let me just walk you through the values as well quickly, I believe. The DevOps roles. Okay, now this is interesting. Again, this lecture or this session was more of around the introductory concepts, because this is most probably the first session for the most of us. And that's why it is more of like the introduction than the deep dive of the tools. Okay, from the tomorrow's session, we'll be doing that. We'll be deep diving onto that. So having said, like I was telling, the roles, the DevOps roles. So it is important to make sure that we are filling in the skill gaps that are there for DevOps. We have to address those. Then only we'll be able to get an opportunity into that and be able to, we will be able to fill in those particular gaps by our skill sets. So talking about the DevOps, we have to address the skill gaps as we discussed. Now, the demand of the DevOps resources the DevOps that is right now. It is difficult to attract and retain the talent. So much demand is onto that right now. The breakneck pace, again, as has been told, at which the program technologies are evolving and ever changing. You'll see the things are getting added, they are evolving over the night. It's making it difficult for the individuals to kind of cope up with that. Okay. And we also have to make sure that the individuals that we're hiring for it, they do have the required soft skills and they should be a good culture fits, adding to the hiring challenge. So basically, there are many challenges. That's what we're trying to convey here. There are many challenges that are there, and with which we have to address in order to fill in ourselves in those particular skill gaps. So training and certification strategy could be one of the very popular one. If you do have a training experience, or if you do have attended a training, or even if you have a valid certification of a particular DevOps course, okay, then it gives you a weightage of value to your overall resume. Immersive coaching, learning, immersion / coaching, supplemental internet teams with outsource talent and recruiting bonuses. Now, these are some of the strategies that you can use, by the way, so that you can fill in the gaps with the DevOps that's been in demand. The skills. What are the skills that are in general required right now? Or the characteristics if you're going to appear as a DevOps professional? Okay, as a DevOps engineer, as a DevOps professional. So some of the skills that are prerequisite are like business value or the business understanding. So you should be understanding the priorities of the business and processes. From the technical point of view, you should be specialist with broad generalistic knowledge, experience, or at least an interest with writing the code. Okay. In fact, we'll be discussing most of the popular tools and services, and as they're saying, broad generalized knowledge, we'll be having that in our sessions. Soft skills which are required is you should be having communication, collaboration. In fact, that's what the basis of DevOps is. And that's the very reason why it is kept as a soft skill as well. In fact, it is a very common soft skill all along, all over. And then self-management, time and stress management, self-motivation, focus. These are some of the skills that you should be taking the initiative, as I just told. These are some of the desired skills that a DevOps engineer should have. Also, along with the characteristics, adaptable, customer-focused, craftsman, curious, data-driven, engaged, empathetic, transparent, honest. Right. This could be some of the characteristics that are expected under the DevOps professional engineer. Now, what kind of roles that we have under DevOps that you can opt for? So this is the list. I'm just not calling each one of them. But let's say the DevOps leader you might be a security engineer, you might be an in the IT support, the DevOps operations engineer, right? DevOps, the release manager. Okay. So they're the roles that are emerging as critical under the DevOps kind of domain or culture. Okay. Now, what is a DevOps engineer? So you see, DevOps engineer is a very, very popular post that we are hiring for. In here, unfortunately, there is no industry recognized job description as such or formal career track. That's why I told you, if you remember while we were discussing DevOps, I told you explicitly that the definition, the understanding, the overall idea of a DevOps engineer or DevOps culture has evolved over the time. Yes, the one that I've shown you was one of the original kind of understanding of DevOps is what we looked at. But DevOps has evolved over the time, and the organizations are adapting it, or actually organizations are using it in many different ways. So again, you see, for the DevOps engineer, the general characteristics which are expected from that person is like the person should be able to should be wanting to contribute to his or her technical talent or business and process improvement initiatives. So basically a productive person is what they're looking for. Is comfortable collaborating with others. So again, you see, it's not individuality that is mattering, that matters a lot in DevOps. It's the communication and the collaboration that you should be bringing to the table. Third, someone who wants to be in a workplace that promotes a shared culture. So it is basically just promoting the best practices of DevOps itself. As a DevOps engineer, you should be fulfilling those if you're going for that role anytime. Now, what are the responsibilities of a DevOps engineer, or as a DevOps portfolio, or as a profile if you have? What are the responsibilities that you have to cater? So if you just have a look at it, DevOps organizational structure, I've told you this already, that depending on the organization, the DevOps culture has evolved over time. In fact, let me just show you quickly. Is if you see, one of the organization, let us say, does have this as a dev. and the other one as ops. I don't want the correctness of my diagram, but just try to understand what I'm trying to convey here. The different ways organizations, they have utilized DevOps. You can see this part will be literally, or this part in fact will be actually the DevOps, not the other Dev and the Ops operations. So it's a minimal kind of approach for, it's a minimal collaboration or communication that does happen between Dev and the Ops. This is one pattern organizations, they do adopt. Second, could be like the traditional one, like we had Dev here, and we have Ops here. Right, so the most traditional one out there, where the Dev and the Ops were working all together differently. And what used to happen in between is that you used to have a big, thick wall. It was with the earlier use cases when the Dev and Ops were not working hand in hand. Third, this is Dev. And you can see Dev Ops. Right, so this is a very common and popular approach, the third one that I'm talking about, wherein it is not a minimal, it is not a very robust, or rather, if you see in the second case, it's literally a thick wall between the two. It's not that, it is not of that kind. But rather in the third type, you can see that two DevOps clusters, or in fact, the Dev and the Ops individual teams, to be very specific, they will work hand in hand together as a single team. In fact, Dev plus Ops will be a single team, and that's what is really ideal. And there is a third pattern. There's a fourth pattern. This is really interesting. That's what, in fact, I have taken you here to have a look at. So the fourth pattern, the organizations have done something really interesting over the time. Is, let's say you have Dev here. Okay, and the fourth one, you see, we have Ops. Now, there are many more teams. In fact, I'll tell you, is DevOps is not limited to Dev and Ops. Over the time, we have added more teams to it. For example, there is a quality assurance team. We have a security team nowadays. Okay, so it has become DevSecOps now. So it is not just about Dev and Ops now. So you see, multiple more teams are getting added. Now, the fourth pattern is really interesting. Is many organizations are doing what now? Is they are hiring for literally a new or entirely new DevOps engineer. So what happens with it is, if you hire a DevOps engineer, it is neither Dev, neither Ops, but it is sort of a bridge between the Dev and the Ops. Okay, and then it carries out the communication between the two, and then it will, it can be used. But there is a catch here, okay, and this is something that has been observed over the time, is if you go with the fourth method, with the Dev and the Ops, in between there is a DevOps engineer, it is observed that after a while, this DevOps engineer will start to dictate what Dev should do, what Ops should do, and they don't take it very, very happily. It doesn't go down well for them. Okay, so you see, because it's kind of a, it's kind of like dictating, instructing what Dev should be doing, what Ops should be doing, and then just being the mediator between the two does not work well. So that's why you see, as we're discussing, the DevOps responsibilities in an organization. Now, this is what we were up to. In fact, if you remember, some organizations they are you can see assigning the ops alliances to the dev scrum teams, or they can create the cross-functional product versus project teams. So again, this is what I'm trying to tell you, is that they have different ways of using DevOps. They adopt metrics or market-oriented structures for setting up the organizational structure, or they create shared ops services that support multiple dev teams. So you can see various approaches are there that have been used and that are being used over the time to support DevOps. And then you see there's an ongoing debate already, and it has always been there, about the pros and the cons of DevOps teams. Okay, individual teams, if you go for the DevOps teams. So creating DevOps departments. So DevOps departments we are creating as such. Okay. The creation of the DevOps departments or teams is growing. It is a growing trend. 22 of 2016 states of DevOps survey respondents indicated they were part of DevOps department. So DevOps teams, what do we have in there? We expand upon the concept of an agile or scrum team. Okay, so we have literally DevOps teams, individual DevOps teams there. We embed the dev and the ops skills into a single holistic group, as we discussed earlier. Maybe temporary or dedicated to specific product. Maybe cross-functional tag alarms of short-term projects. You can see dev and ops skills into a holistic group. That's what is the way to go forth. May evolve to provide shared services, if at all, and have shared accountabilities as well, depending on if you're a developer or if you're an ops person, you'll have one or the other responsibility in hand. After, you see, you should adhere to the defined standards for development, automation, risk, compliance that applies to all DevOps teams. Okay, so DevOps teams, in fact, I'll tell you from the AWS's perspective, those DevOps teams, Jeff Bezos, in fact, calls it as the two pizza teams. Okay, so basically a combination of the best of the two. The downside of having a dedicated DevOps team. The downside could be like, if you have dedicated DevOps team, rather than having dev and the ops working together, then less engagement you'll see across the other IT value streams. The risk of being another silo. So that's the reason why we, in fact, created DevOps, right? We wanted to break the silos between the dev and the ops. Now, if you bring in the same DevOps, you will see there's some. So DevOps activities, like I was saying, become someone else's problems. Okay. Regardless of structure, the DevOps team should be flat with continuous engagement. Marcel is, I believe, typing something else. Anyway, so regardless of structure, DevOps teams should be flat with continuous engagement and the right balance of people, practice, and automation skills. Okay. Again, these are some of the patterns that have been observed over the organizations. They are using it in one or the other way. Okay, we are just exploring that. What are the patterns that are out there? Okay, that the organizations are kind of going with. Talking about the DevOps improvements, there are 8 steps to transforming your organization. Okay, as far as improvements under the DevOps is concerned. Establish a sense of urgency for the matters which are important. And in fact, for every other matter, it should be a sense of urgency just to carry the things out in the fastest way possible and as quickly as possible, rather. Create a powerful guiding coalition which will guide us going into the DevOps. Develop a vision and strategy to basically where we are heading to, if you go with it. Communicate that vision to the counterparts, to basically your employees, your friends, your colleagues, in fact, from the organization especially. Create short-term wins. So you see, it is important that don't look at the entire application as a whole, like it was discouraged already. So instead, look at the short-term wins. Look at individual microservices, isn't it? Rather than entire application as a whole. Consolidate gains and produce more change, and anchor new approaches in the culture. Okay, so these are some of the steps that allow us. So start where you are. DevOps is not your why, not your co-workers' why, certainly not your business's why, right? As it's been told there. But ultimately, start where you are at, or start where you are. So you should be understanding the business value, or you should be understanding the value that it brings in. For example, you see, you should be clear on the business opportunity. You should get the right people together. So you see, again, it's not as simple as it seems, and neither it as simple as it sounds. Okay, telling them, okay, bring good people together, not so easy, you see. You would require the talents that can justify that particular post. Get everyone on the same page so that everyone will know exactly where we are heading to. Invest in training and skill development. So you see, more you invest in your upskilling of your employees, better that would be when we will move on to DevOps as such. Isn't it? They should be aware of what are the prerequisites, what are exactly the expectations of a DevOps team, or as a DevOps engineer, or as a DevOps employee, or as a DevOps engineer, or as a DevOps sort of cloud expert. Right. Now, you see, we'll have a look at that. Don't worry. We'll have a look at that. What exactly is the issue with it? Don't worry. Talking about it further, build capabilities that lead to lasting change. So again, when you're taking on something as huge as DevOps, your workforce should be capable to handle it and to be able to tackle that. And for that, it's important to build the capabilities, abilities that will help or that will lead to lasting change. You should be focusing on critical behaviors which are important. Experiment and learn as much as you want. You should be experimenting, as being already told multiple times before. Because in DevOps culture, more experimentation, more innovation. It is said to be directly proportional, the two things, experimentation and innovation. And avoid inertia. I believe that was a last one. Learn by doing. So it's not just about planning. It's not just about thinking it out. It's as well about moving and going ahead and doing all of it. So you see, you should be create a pilot where you can maximize the probability of success. It should be small enough where success is apparent and understood. And consequences of the failure aren't so large that mistake could shut down the entire initiative. That as well you should be taken care of. So you see, I've already told you, right, multiple times before, it should be a risk should be calculated. And the consequences should always be thought of beforehand, isn't it? So if you're taking up a risk, and it's not just about in real words, but in cloud as well, the risks, they can be really worth it. It should be large enough that, okay, see, first they are telling it should be small enough that the success is apparent and understood, and consequences aren't so large. But it should be as large as you should show proof of improvement. You should be able to show what percentage of improvement that we have achieved by means of this DevOps culture. And you earn the right to make the future improvements as a part of that. Now, the consolidated gains and produce more change is what's expected under it. So you should communicate the success, failures, and lessons learned that you have, so that the people to follow, the leaders to follow, or rather the students that will follow beyond. So these success stories, these failures, and these lessons, they will help them not do the same mistake over and over again. Expand, document, and make available reusable artifacts and measurements. Isn't it? Then expand your cycles of improvement. You should be expanding your cycles of improvement beyond. You should be continuously investing in upskilling, education, and introduce advanced tools and techniques as needed. In fact, team, again, I'm telling you one more thing, or repeatedly the same thing, that yes, this module is a lot more theoretical. We are just looking at the best practices and the guidelines as given by under the DevOps. Okay, so don't worry. We'll be having a good look at the different tools and the services and the demonstration and everything from the next session on. Okay, we are just right now looking at the DevOps as a whole. Okay, and then we'll deep dive into it. And right now, today, we are just scratching the surface of it. And from tomorrow on, it'll be the real deal. It will be literally working with individual services. Okay. Anchor the results, like I was just telling, prove that the new way of doing things is better. So again, that's the flexibility that DevOps should provide you with, because now you're no longer stuck with a big application code as such, like earlier. Right. So if you go and if you're convinced that the approach that you're going with is the best one, you should be proving that the way that you're doing it is better than the traditional. Reinforce new behaviors with incentives and rewards. So again, this is a strategy that you'll have to deploy in your organization to make more out of them, or to take out more out of them, and basically make sure that you will speed up the process of adopting to the cloud and getting familiar with it, the DevOps environment. Be prepared to lose some people along the way. Again, that's probably, and that's, you see, that's really, really important. Lose mainframe guys, isn't it? So yes, again, you see, at times this is a real possibility, and this is bound to happen. That's why you see, ultimately, I have been telling you all along that DevOps is more of a cultural shift, not just a technology or a tool or a method or a service. And that's exactly for that very reason that you see, you will literally have an entire different mindset when you're onboarded as a DevOps under the DevOps team might be, right? So you should be prepared that on the way you might be losing your fellow developer colleague or a fellow operations colleague, depending on which team you are going in with. And reinforce the new culture with every new employee. So it is important that your new employees, or every employee rather in your organization, should be aware of what approach we are going with, what are the benefits of that, and why we are moving from the existing architecture that we had towards a newer architecture. Isn't it? Having said, if I just go down, You see, next, the DevOps practices is something that we'll be looking at, but that we'll be looking at in the further stages.